a calculator to calculate some of these trig values. So today is actually using trig functions, like I said, to find side lengths or angle measures of right triangles. So I do want to specify that. We'll be getting into problems that will require you to use trig to find side lengths or angle measures of triangles that are not right triangles. So it's important for you to understand when to use these types of equations. What do you do when you have a right triangle versus what do you do when your triangle is not a right triangle? And yesterday we looked at finding exact values when you had 30, 60, 90 triangles or 45, 45, 90 triangles. Otherwise, if you do not have one of those special angle measures, you can use a calculator to find the value of the trig function. So in example 1, it says use a trig function to find the value of x. So we're finding that missing side length. Round to the nearest tenth if necessary. Today you'll actually be rounding because you can see the angle we have is 24 degrees. It's not 30, 60, or 45. So based on that 24 degrees, we're going to work through this the same way we worked through the last examples yesterday. Figure out in relation to that 24 degree angle what side lengths the 11 and the x are. So what would the 11 be, the opposite, adjacent, or hypotenuse? With respect to 24 degrees. The opposite. And then what about the x? The hypotenuse, yep. So then what trig function would you use if you have opposite and hypotenuse? Sine, cosine, or tangent? Sine. Opposite over hypotenuse is sine. So I would set up this equation, sine of 24 degrees is equal to opposite over hypotenuse, so 11 over x. Okay, and then I'm going to rearrange this before. This is going to end up having to be typed in the calculator to figure out what sine of 24 degrees is. But before I type anything in the calculator, I'm going to rearrange this to get the x by itself. How would I get x alone? What would I have to do to this equation if I wanted to solve it for x? Sine of 24 degrees, that alone represents a number. So we'll type that into our calculator to get a number. I'm just going to do that at the end. What do I have to do to solve for x? I'm guessing nobody wants to say it because hopefully you know how to solve this for x. I would not multiply by 11. Multiply by x. Since the x is in the denominator, if you multiply by 11, that will not cancel out this 11. But Sarah, I'm glad you said that because that's why I was waiting for somebody to respond, because that's what students tend to do is they would look at this and say, oh, multiply by 11, and then this side will equal x. That does not work for this. So I would multiply by x so that x is not in the denominator anymore. So I would have x times, I don't need this in parentheses, I just put parentheses around it so that you understand that is one number that is representing a value. So x times sine of 24 degrees equals 11. Then what do I have to do to get x alone? Divide by sine of 24 degrees. Okay, and I've talked before with problems about not rounding in the middle of a problem, so that's why I didn't type sine of 24 degrees into my calculator initially and get a decimal and round it. I want to make sure I'm not rounding anything until the very end. So I'm going to get x equals, and now in my calculator I can type in 11 divided by sine of 24 degrees. And you should, on your scientific calculator, you should have a sine, cosine, tangent, like actual keys for those. If you have a different type of calculator, I know some of you have your own graphing calculators. If you have any questions on how to use your calculator for trig, let me know. But you should also make sure, and everybody can look at your calculator right now, but again, different models, I'm not sure if it all shows up the same way. Notice on mine, this right here says DEG. That means it's in degree mode. And if my angles are measured in degrees, I want to be in degree mode. There is a different mode, radian mode. We're going to be learning about radians in this chapter. If you're in radian mode and you type in a degree measure, you will get a different answer and it would be incorrect. So I guess if you type this in right and you're not getting the right answer, your calculator might be in a different mode, and I can check that for you. So sine of 24, close the parentheses, hit enter. So you should get, it did say round to the nearest tenth, so 1 decimal place, so 27.0. And if it says round to the nearest tenth, you should write the 0.0 to show that you have that tenths place. So 27.0 would be the value of x. Anybody right now, just so it's not messing you up for the rest of the examples, anybody not getting this on their calculator? Okay. So that is x. Any questions on that? All right. Then the next set of examples we're going to go through are finding angle measures using trig functions. And from what I know, this is probably also some review. So this is where you would use inverse trig functions. So it says here, I just have a way to explain, or rather for you to relate back to something you already know, why we have inverse trig functions. So when you're solving an equation like 3x equals negative 27, you're using the inverse of multiplication, which is division, to find x. So when you divide by 3, you are using the inverse process of multiplication. So you can find angle measures by using the inverse of sine, cosine, or tangent. And I'm going to write these for you so you see how they look. I did copy this here for you to help explain this. So you can kind of see here what I'm going to write down. This expression, so if you see sine, it looks like sine to the negative 1 power and then x. You don't say it that way though. That's what it looks like. That's how it's written. But that means the inverse of sine, or inverse sine. So that notation is read as the inverse sine of x, and it's interpreted as the angle whose sine is x. So anytime you're trying to find an angle measure, you should be using inverse sine, inverse cosine, or inverse tangent. If you're trying to find a side length, you're just using regular sine, cosine, or tangent, or the reciprocals. And then it does go on to say to be careful not to confuse it with the notation for the reciprocal. So inverse sine is not the same as 1 over sine. 1 over sine is cosecant. That's the reciprocal function. Inverse sine is something totally different. This notation is similar to the notation for an inverse function. So you might remember inverse function notation was f and then negative 1 of x. So it's that same notation, that little negative 1 that looks like an exponent, but it's really not. So if you see sine negative 1x, so I want to make it clear, I know I'm saying it that way so you know how to write it. That's not how you actually say it though. So this means inverse sine. And then if you see that notation with cosine, that's inverse cosine. Same with tangent. And these are used to find angle measures for a right triangle. There is not an inverse cosecant, an inverse secant, an inverse cotangent. So it's just sine, cosine, and tangent, the main three that have inverses. So what I have here already typed out is to show you how it's used. So if you had this equation, sine of some angle A is equal to 0.5, and you wanted to find what angle A is, the reason we have inverse trig functions is you cannot divide by sin. You cannot divide by sine. Sine means nothing, sin means nothing without an angle written after it. So you can't divide by sine, cosine, or tangent. It's not sine times A, it's sine of A. So that's why we have to take inverse sine of both sides. Inverse sine and sine cancel each other out. Inverses cancel out like addition and subtraction. So then you're just left with the measure of angle A would equal, and you could type inverse sine of 0.5 into your calculator. So again, if you can't find this on your calculator, let me know. If you have a scientific calculator like this one, if you look above the sine, cosine, and tangent keys, you see inverse sine, inverse cosine, inverse tangent. So I would have to hit second sine to get inverse sine, and then just type in 0.5 and hit enter, and it'll give me the angle measure. So the angle would be 30 degrees.
Oh.
So, like I said, that angle would be 30 degrees if you want to write that in that blank. All right, so I'll fill that in here. Measure of angle A would be 30 degrees. So we're going to be going through examples. Again, if you're asked to find an angle measure, you would be using one of the three inverse functions. So example 2, actually 2 and 3, find the measure of each angle. That's labeled for you, round to the nearest tenth if necessary. So for example 2, here's our angle x that we're looking for. So again, you want to start it the same way we started example 1. Identify the two sides you're given if they're opposite, adjacent, or the hypotenuse with respect to angle x. So what would the 15 be? Opposite, adjacent, or hypotenuse? Adjacent, and what's the 17? So what trig function would we use if we have adjacent and hypotenuse? Cosine. Cosine is adjacent over hypotenuse. So I would write this first as cosine of x is equal to adjacent over hypotenuse is 15 over 17. Okay, but then I'm looking for an angle measure. So that tells me I have to cancel out this cosine. I have to take inverse cosine of both sides. So what this would look like, I'm going to write it all out like this one was written. So I would be taking inverse cosine of x. And then I have inverse cosine of the other side, 15 over 17. And the inverse cosine of cosine, that cancels out. So on the left side, I'm just left with x. And the inverse cosine of 15 over 17, I type into the calculator. And if you wanted to, just kind of skip, if you didn't show this necessarily, that's fine. I'm just showing you where that's coming from, where we're getting our value, what we're calculating. So I would type in second cosine for inverse cosine, and then just type in 15 divided by 17, and then close the parentheses. Hit enter. Rounding to the nearest tenth, our angle would be 28.1 degrees. Any questions on that one? Okay, go ahead and find angle x for example 3. Make sure you can set this up and calculate it on your own here. quick walk around so if you have questions, let me know.
Oh, yeah, I just overdo.
It's because it's like,
Yeah, well, I have mom.
whatever is opposite of that,
27 innovation is the
not the smallest.
Well, what you're trying to figure out the little corner area, that's why I like but it's a triangle. Why are they triangles so difficult? I don't know. We're trying to get it right. Okay.
So this is opposite, this is adjacent. All right, just double check. Not all of you were quite done when I walked around, but seem to have the right trig function identified. So 56.3 degrees. And part of it is identifying with respect to your angle what's opposite, adjacent, hypotenuse. So make sure that you're comfortable with that, because if you get that mixed up, your answer will be incorrect. Okay, so then moving on to the last two examples, these deal with angles of elevation and depression. And I know like this diagram might be a little bit hard to see. So in this figure, what's supposed to be happening is there is a person down here in the lower right swimming. That's what that's supposed to be. And then this would be a lifeguard here. So in this figure, it's saying the angle formed by the line of sight from the swimmer. So the line of sight from the swimmer to the lifeguard would be here. And the line parallel to the horizon, which would be the horizontal line, so from the swimmer would be here. This angle that is formed is called the angle of elevation because you're elevating up from the horizon. Versus the angle formed by the line of sight from the lifeguard, so that is going down to the swimmer in the diagram, and the lifeguard's line of sight parallel to the horizon here. That angle, because it's going down from that horizon, would be the angle of depression. So when a question or example is talking about an angle of elevation or depression, you need to identify what angle they're talking about. And so that's what we're using in these examples 4 and 5. So 4 says a ramp for unloading a moving truck has an angle of elevation of 32 degrees. So you can kind of see there's the back of that truck that's coming down here. The angle of elevation they're talking about would be then from the ground, or using the ground as that horizontal of your triangle. So it's talking about this angle here that is 32 degrees. And then I can kind of finish this off so you can see how that right triangle would be formed there by that ramp. So it says if the top of the ramp is 4 feet above the ground, estimate the length of the ramp. So I want you to think about this in the triangle, because this is up to you then to just set up the triangle based on what's being described. So it says if the top of the ramp is 4 feet above the ground, so which side length of our triangle is 4? The opposite side length, adjacent side length, or hypotenuse? The opposite. So opposite of 32, this vertical length, that is the side length that is 4. We are then estimating the length of the ramp. So which side of the triangle are we trying to find? What side of the triangle is the length of the ramp? The hypotenuse, yes. So I'm going to call the hypotenuse x. Once you have it set up, now you're doing what we did in the previous examples. Here we're trying to find a side length, so we have to set up a trig function to do so. So if we have the opposite and the hypotenuse, what trig function are we using? Sine. So I would set up sine of 32 degrees is equal to opposite over hypotenuse, so 4 over x. This is similar to the first example we went through. Your x is in the denominator, so I would first multiply both sides by x. Again, that sine of 32 is representing a number. So I have x times sine of 32 degrees equals 4, and then divide by sine of 32. So I can type into my calculator 4 divided by sine, not inverse sine, just regular sine of 32 degrees is equal to, and we'll just continue rounding to the nearest tenth, so about 7.5. And that was measured in feet. So the ramp is about 7.5 feet long, 7.5 feet long. Okay, any questions on that one? So the application part of it. 5, I'm going to have you do. I just want to help you picture what's going on because there isn't a diagram given to you. So it says the hill of a roller coaster has an angle of descent or an angle of depression of 60 degrees and its vertical drop is 195 feet. Estimate the length of the hill. So if you picture, say you have a hill of a roller coaster, so you're coming up and then your hill is going down like this and then it does whatever after that. So say you're right here on the roller coaster and they're thinking of this as being straight. So this would be one part of your triangle. You could draw a right triangle off of this like this, just to help you picture it. So part of it, when you, I would definitely recommend with the practice, for this one you'll have time in class to work on the practice, because part of it is just sketching what the triangle would even look like. So based on that triangle, I want you to answer number 5. You'd have to figure out where the 60 degrees goes, where the 195 goes, and then what are you trying to find. I didn't draw this the greatest though. I probably should have drawn like the whole thing as one triangle. That's not the best drawing. Sorry about that. Not totally accurate. Maybe you want to draw yours better. But anyway, do number 5. I'll come around, I can check, answer questions, I'll pass up the assignment. You do have just about 20 minutes here to work on it. There's no reason it should just be put away. Even if you feel comfortable with these examples, you have 20 minutes to practice it, and a lot of these questions on the practice are setting up triangles on your own. So use your time to do that, or even do yesterday's assignment if you didn't do that one.